since A prime belongs to En, so I can move forward to B prime. Lambda is not equal to 0. A prime can be represented as a linear combination of A1 to AN, so to the B prime. So maybe we can a sequence of transforming B to a certain point. Then I can easily prove this bridge. Then once this bridge is okay, then the final result is proof. This is what we call a forward and backward method. Did that make sense? That makes sense? So we start from the original fact, the assumption and the conclusion. We're trying to get them into a place so these two can match. Does that make sense? I know this is a little bit abstract. You've probably never seen this in classroom before for proving a theory. Gradually, we're going to start talking about more formally, introduce several different techniques. Okay? In the technique called, many times you see in the theorem say, for all. Okay? For all things like this must happen. How do you prove for all? Oh, there is. So the proving technique for all and there is are totally different. For all, you must prove every single case that this is true, okay? But there is, only thing you have to prove, there is one case is true. Did that make sense at all? So we'll show you how to prove these kind of logic later on. There's a training for logic. Okay, the difficult stuff finished. We're going to start talking about easy stuff today. Just a couple of definitions before I let you go. All right. Page, let me see. Page 15. Talking about matrices. Matrix A is a whole bunch of column vector element, we call it Aij. First dimension is row, number of row. Second dimension is number of column. Here are the notation. Or we can represent it as a row number of column, just column vector, correct? Superscript usually in the textbook represent row. Make sense? Row vector. Subscript represent column vector. So I have how many row? N row, N column. A element addition. Okay? Matrix multiplication, number of rows in the front matter has to be equals to number of rows in the post vector, post matrix. So that means we call the rank agreement. The inner of these two dimension has to be agreed. Okay? In this case, B times A is invalid. Why? N may not be agreed with M, correct? So this is P by N, M by P, unless M equals to N, correct? And also, an identity matrix of N is conditioned by E1, E2, all the way to En, which means a square matrix with a diagonal 1 and off diagonal all 0. We call that identity matrix. It's a composition of a univector. I M times A M. Identity matrix times a matrix equal to itself times identity matrix of N. Inner has to be agreed, correct? So identity matrix is a square matrix with dimension the same, equals to B. All right? So if A equals to A transpose, and we call this matrix symmetric. Matrix. If A equals to negative A transpose, so we call it skew symmetric. Okay, I think we about done, and then we're going to continue next lecture period on Thursday, starting the partition of matrices in page 15.